Hi everyone, welcome back to workshop, and it's repair time again, and this time something a little bit different. It's one of my own pieces of test equipment or power supply that I actually use in the workshop myself. This is a BB3, it's called. It's an EEZ BB3, a Benchbox 3. It's an open hardware, open source power supply designed by a company called Envox, and basically you buy it in kit form and you can put in any amount of different types of modules into here. As you can see, I've got 3 here, and the reason I've got one of these is because they're really configurable in terms of how you control the output. You can remotely control it, can do that via GPIB effectively, or Skippy, and also it's touch screen. It's easy to step through different voltages when I'm using the power supply to test, for instance, my PDVS2 minis, where I want to go up in different steps of voltage when I'm testing brand new boards, rather than just whacking in 20 volts, etc. So you can do that, and it's got a rotary encoder on the front. Like I said, it's touch screen. You can configure the screens differently, as you can see here. There. And obviously you've got full control over the current output as well as the voltage. It's all touch screen. You hit a button here, and now I'm going to adjust the set current there that I've got it set to. So, you know, 500 milliamps or back to voltage there. I can control that. Up to date, it's been working great. I've got 2 different types of modules fitted to it. I've got 2 DCP 405s. They're effectively 0 to 40 volt, 5 amp each, as you can see there, with some remote sensing capabilities on it. And I've got a much more basic module on the end here, a DCM 220, which is dual channel, which is 0 to 20 volt, maximum 4 amp. And it's this second channel here, down here, that's actually developed a little fault. So I'll just try and demonstrate that fault right now. It doesn't always do it, but we'll see how we get on. If I turn it off and let it all the power dissipate. So I've left it for a few minutes now in the off position, so hopefully everything's dissipated now. So if I power it on, what you want to be looking at is this LED here. Basically all the modules or all the channels have got a green or a red LED that will show in that positions there. And basically green means it's in constant voltage mode, red means it's in constant current mode. So obviously with nothing connected to the outputs and the channel switched on, you effectively should be in constant voltage mode, and that would be indicated by the green LEDs. So you should be getting 4 green LEDs. But channel 2 here, sometimes when I power it up, it stays in constant current mode with the red LED just for a few seconds after power up. In comparison to like channel 1 here, it'll be immediately switch to constant voltage mode. But sometimes channel 2 will sit for 30 seconds in constant current mode. So I'll just power it up now and we'll see what happens. There we go, got a red LED, and because it's stuck in constant current mode, or it was, didn't take long to switch there. This is the output voltage that we're monitoring from the output. This is the set voltage there, and that's the output that's been measured on the actual bananas. And that voltage there would be way down at well, just about 1 volt or even less, half a volt, something like that, when it's stuck in constant current mode. So sometimes, like I said, it's stuck for 30 seconds or almost indefinitely sometimes. And it seems to be that if I switch it off now and then switch it on again without waiting for everything to dissipate, it's fine. It goes green straight away, as you can see there. We've got I've set 20 volts and I'm measuring 20 volts, so it's fine. It only seems to be on a cold boot. Perhaps it's you know, it's hard to say because I haven't switched it off and on that many times to really nail it down when it's happening. But certainly in cold boot, it does seem to be more apt to go into constant current mode. So I did actually speak to the Discord group where Envox hang out, and you can report faults, etc. like that, or discuss the power supply in general. And I did mention it there on the Discord channel, and I was told that yes, there was some problems with the DCM 220. There's an IC on the board which wasn't necessarily soldered properly. There's a thermal pad on the underside of the IC, wasn't reflowed properly by the assembler of the actual circuit boards, and it could possibly be the fault. So I'm not too sure about that unless it's required for an electrical connection other than its thermal conductivity. I'm not really sure, because like I said, it's on cold boot. When everything's stone cold that you switch it on, you'll get that problem, and it's not happening like when it's under load and everything's heating up, you know, the IC's theoretically heating up inside the power supply. That's not the case, but like I said, it could be an electrical conductivity problem rather than a thermal, but certainly it's on the thermal pad. So the answer to that is to desolder that IC and replace it. I've got a new one, and we'll replace it, reflow it properly on the workbench here, and we'll try that. And if we've still got a problem thereafter, then we'll need to start troubleshooting. Now, the good thing about having an open hardware design is that I do have all the schematics. So this is a schematic for the DCM220, or one of the channels anyway, so we'll be able to troubleshoot that and hopefully get it working. Okay, let's power it up and see what happens. Yep, and everything's reported okay. As you can see, I've got the LEDs on the front of the unit okay. Let me just turn off channel 1 because it's working right now. Yep, and we've got the LEDs going off. So it looks like we've got good communication with the card. Great, can start troubleshooting now. Well, all the control signals all look fine, and I've compared it actually, some of them to channel 1, because we've got a good working channel, and everything seems identical. Even the output enable, which I haven't mentioned as yet, there's an output enable for the actual 3763, which comes from the touchscreen effectively, which disables the whole thing, but that turns off both LEDs, so I know it's nothing to do with output enable. So it is pointing towards a 3763 problem, so let's whip it off the board and put the new one in its place and see how we go for there. Now, if it's got a thermal pad on the underside, it's probably not going to be that easy to remove, but a good bit of heat and a good bit of airflow hopefully should do the trick. And there we go, and you can see the thermal pad on the underside, which looked fine. Out of interest, there's a good bit of solder on the underside of the IC, so not too sure at the moment, but we can only try changing it and see what happens. Right, I have gone ahead and desoldered the LED driver IC, and on first look it did look okay. The solder pad on the underside did look like it was okay, but then again I started looking at some of the other joints in the board, and they are very grainy looking, especially on some of the bigger pads. So I went ahead and desoldered both of the MOSFETs on that channel. I don't suspect there's a problem with them. However, they are got quite a lot of solder on them, and I just thought I'd take a look at it. And to tell you the truth, they came off very, very easily with very little heat, and they basically just fell off the board. Not the usual amount of heat or airflow required from my 861D to actually remove them. And so I started prodding around at some of the other solder joints at the board. Now let me just turn it over, and I haven't actually touched this one here yet. You can see, if I can zoom in, that it is very, very grainy looking. Now, I haven't touched that one. Obviously this one here has been reheated by me taking off the IC, but this one here I haven't touched, and it is very, very grainy looking. Now, what I did find that when I desoldered the MOSFETs, it appears like it's very layered looking, the solder, and hence with just a little bit of heat it fell off the board. It doesn't look like there was much adhesion between the underside of the MOSFET and the actual board itself. It came away too easily. So I started putting the soldering iron on some of the other joints on the board round about here, and to tell you the truth, I had a hard job adding new flux to those joints in order to reflow them and try and make them shiny again, and it wasn't taking very well. So I suspect that the solder is actually not reflowed very well at all, and it's probably the problem with this board in the first place. So this one here is very much like that. So let me take the soldering iron and reheat that one there, and let's add a bit of new solder to it and see if I can attach a wire to that, see if I can demonstrate what I found with some of the other pads. Right, here we go. Look at that. Just, I left it for it long enough for it to attach properly, but it just falls away, and you can see that there's no shininess to that at all. Let's do it again. This time I'll leave it a bit longer. I'm blowing on it very, very slightly. It's attached itself there, but I mean the lack of shininess on that. So I think that's the same reason why my MOSFETs basically fell off the board when I heated it up. I think the solder has not reflowed at all. Graininess can happen when you're reflowing a board and you let it cool down in your reflow oven too slowly. If it's too slow, grain can appear, and therefore maybe that's the problem with this. Now if I remove this solder completely, let's wick it all up. There we go. And I'll clean the soldering iron and put on some fresh solder. And I'll cut my wire back. And then try attaching this wire. And there you go. We've got a nice shiny joint there now. So definitely a problem with the solder. And perhaps that's the original problem with this particular IC here that I was pointed towards as possibly having a reflow problem on the underside. Perhaps it wasn't making a good joint. So the next step is to, I've actually got another IC, a replacement here, so I'm going to put the MOSFETs back on, put the new IC in this position here, and let's power it up and see what happens then. Right, so I'm going to put the new chip on now. I'll put a little bit of solder paste on the pad itself, in the centre of the pad, because it will get squeezed out a little bit when I put the IC on. You don't want too much, because you certainly don't want it squeezed out so much, especially when it reflows, that it gets to the pins at either side of the pad. It shouldn't do, because there's quite a bit of solder mask as a barrier there, but you never know if you really put far too much. So the idea is, I'm going to put the chip on there, and I'm actually going to tack a couple of pins at either end of the IC just so that I can then reflow it. So I'll just go in and do that now. So what I'm going to do is I'm going to put some flux on the pins, and I'm going to go along and resolder all the pins, And then I'm probably going to reflow it from the underside. There's a big pad without solder mask on it on the underside, so I can heat up the underside in order to reflow the new paste that I've put underneath the IC. Don't really want to put too much heat onto the IC, hoping that the heat will go through, so I'm going to do it that way. Right, so I'll away and solder that now. Can't put this on camera because I need to get my head right over it, so I'll come back in a minute. And there we go, it's all soldered up. Still got plenty of flux all over it, but I'll get some IPA and get rid of that, but I'll do the underside first. Okay, right, I've powered it up and it's worse. To be expected. I have been removing ICs, transistors, etc. and mucking about with the board quite a lot, and it's basically stuck in CC mode all the time. Now I think the output stage here and through the inductors and everything like that, everything's okay there. So I've turned to the chip that I just replaced and started looking at the circuit round about it. And let me take you to the schematic and see what I've found. So up at the top here you've got your main 50 volts from the external power supply, and you've got a couple of control voltages as well. You've got an 8 volt, although that's not actually used. That diode's not fitted. As you can see, it's greyed out. You've got some control, looks like, to the power input of this chip. So I started looking around here because when I measure pin 3 of this IC, it's stuck at 11 volts. Now it should be up at 47, 50 volts, something like that, when the channel's enabled and it's up and running. So I started looking at this part here where the incoming power comes in, and this R52 10 ohm, I'm measuring that a lot higher than that. Let's take a look. 28.7k. Wow. So I think I'll try reflowing that resistor there and see if it improves anything. It's gone up 9.9 meg ohm. That resistor's gone, so I'll change that one out and we'll see how we go for there. Okay, we've got it ready for power up. New resistors in, and let's put power on. And we've got a green light straight away on channel 2. I've got my electronic load hooked up off camera, just ready to start testing the output, but I am getting 20 volts on the output, as you can see here, and it's no longer jumping around. But the important thing is, on power up, what's that LED doing? Have I fixed the problem? So let's switch off again. Let power dissipate for a few seconds and then I'll turn it back on again. And we'll keep our eye on this LED. In fact, I'll disconnect the electronic dummy load. There we go. So we're looking at this LED here. I'm expecting it to see it come on green at the same time as channel 1. That looks good. But of course the problem just became more apparent when I had power off for quite a while and let all the power dissipate. So I'll do that next. I'll come back in a minute. Okay, it's been off for about 15 minutes now, so it's time for another check. Keep our eye on the LEDs there, and let's power it up and see what happens. Yes, that's more like it. Brilliant. Okay, I think I'll put the card back into the unit now and give it another check. Of course, I'm going to have to test this quite a bit, and power it off and power it on over the next few days, just to make absolutely sure the problem's fixed. But it's looking good at the moment. Okay, here we go. It's all back together again. Of course, it's been off for about another 15 minutes, so let's power it up and see what happens. Yep, 2 greens. And I can disable the channel there, disable the other one there, and of course those ones will disable as well, no problem. Perfect, 20 volts output, nice and stable. So that's it. So what was the problem? Well, the 10 ohm resistor was certainly breaking down. It was probably intermittent and was sometimes working, sometimes not on power up. And of course I had I was advised the the LED driver chip would possibly got a reflow problem, so I just changed that as a matter of course anyway. But like I said, what I also did is I went over some of the joints on the board and replaced some of the solder. Really a bad consistency, which I think was probably caused by maybe the reflow cycle was too long when the board was originally manufactured. That can make brittle joints, certainly, and it's a telltale of that is they're rough looking joints, are not shiny. And you know that can be caused, like I said, by a reflow cycle that's the cool down period is too long. It should really be, you really got to follow the profile even on the cooling down cycle if you want a perfect shiny joint. But anyway, that's a back up and running. I'm glad I got channel 2 and the DCM 220 working, so it's back into operation for the power supply. Thanks for watching.